For your warm-up today, I want to put you through a little algebra exercise that is going to lead very well into what we're doing today. So I want you to simplify this expression. I want you to combine these two rational expressions by finding a common denominator. Please pause the video and allow students 2 to 3 minutes to do this. Okay, again, this is an algebra problem. And so to get a common denominator, I notice that these two denominators have no factors in common, which means I'm going to take the first term and multiply it by x minus 5 over x minus 5. I can do this because x minus 5 over x minus 5 is equal to 1, and multiplying by 1 gives me my identity back. The second, I'm going to multiply by 2x plus 1 over 2x plus 1 for the same reasons. So this becomes, I distribute this 2 through, 2x minus 10 over 2x plus 1 times x minus 5 plus 6x plus 3 over 2x plus 1 times x minus 5, which if I combine these two together, since I can with equal denominators, I get 8x minus 7 over 2x plus 1 x minus 5. Or if you multiplied the two binomials in the denominator together, you would get 8x minus 7 times 2x squared minus 9x minus 5. I'm pretty sure that's right. This gives me x. This gives me minus 10x, so that's minus 9x. Okay, what I want to do now is have you all get your homework out from last night, and at the very least I can put up solutions to last night's homework and give you guys a chance to discuss. So here are the answers to homework number 1. The odds you should be looking up on your own in the textbook and trying to figure out where you went wrong if you got those incorrect. The evens, here are my solutions. And I'd like you to pause the video for as much time as you need so that people can ask questions of the group. And if I have some brave souls that are willing to go up to the board and answer those questions, I would really appreciate that. I know that this is probably the biggest difficulty of me being out right now is that you can't ask me questions. You can't ask me homework questions. You can't ask me questions when you get confused during the lesson. And I get that and I sympathize with you. And so you all need to really rely on each other for this. Don't be afraid to ask questions. Don't be afraid to answer questions if you know how to do this. Okay? So please pause for 5 minutes, more if you need it, to get people's homework questions answered. Okay. Hopefully that was helpful. Please get used to doing this. It's really, really very important. All right, so you were probably wondering why I had you do that funny algebra warm-up. And the reason for that is because what we are going to learn today is the method of partial fraction decomposition. And partial fraction decomposition essentially means going backwards from what you did in the warm-up in order to go from an expression that cannot be integrated as it is into one that can. So first of all, I want you to take a look at these two integrals and just kind of shout out the preliminary differences between these two integrals. Hopefully you noticed that the difference is that the denominator of this one is x squared minus x plus 6. This is x squared plus x minus 6. That's kind of the superficial difference. The more mathematical difference is that in this first one, the derivative of the denominator is the numerator, which means I can use u substitution. In the second one, the derivative of the denominator is 2x plus 1, which is not a multiple of the numerator. So the second one, I cannot use u substitution. So this first problem is, similar to what we did yesterday. It would be pretty easy. But this second one, where you're sitting right now, you can't do this. Okay? You cannot integrate this using what you learned in Calc AB. And so what I'm going to teach you today is how to integrate something like this. What I do notice is that the denominator of this second integral is factorable. X squared plus x plus 6 can be factored into the product of two binomials. And so since the denominator is factorable, we can use the method of partial fraction decomposition. So let me begin by reviewing partial fraction decomposition. This is an algebra skill. This is not a calculus skill. So I don't know when you learn this, Algebra 2, pre-calc, maybe they've removed it from the curriculum at this point. I don't know. But I'm going to teach you what you need to know. The majority of today's lesson is going to be focused on the algebra that you need in order to do this. Once you perform the algebra, the calculus is actually very easy. And so the idea of partial fraction decomposition is to take a rational function and decompose it into simpler rational functions, which can then be integrated. In our warm-up, you had two simple rational expressions that we added together, and what we're going to do is basically take what we did in the warm-up and go backwards. So go from something that looks like this and break it into the sum of two simpler rational functions, which can be integrated. I hope that makes sense. There is a medium way of doing this as well as an easier method. I'm going to show you the medium way because I've got to show you good algebra, and then I'm going to teach you a shortcut. You can use that shortcut, but I do need you to follow me in this slightly more difficult method. So what you have to do first is take your rational expression and factor the denominator. So I see x squared plus x minus 6. I'd like to factor it. And I believe that factors into x plus 3 times x minus 2. You can always check your work with these. This does work out. We're good. Then you need to split that factored function into the sum of two partial fractions. I'm going to say that 2x minus 1 over x plus 3 times x minus 2 is equal to some constant, a, over the first factor, x plus 3, plus some other constant, b, over the second factor, x minus 2, okay? There are algebraic theorems that tell us that this is a true statement. I don't want to get into that, but essentially I can split this into the sum of two partial fractions. One partial fraction's denominator is equal to the first factor, the second is the second. The order doesn't really matter. And then what I'm going to do is solve for those constants. The way I'm going to solve for those constants is essentially by doing what we did in the warm-up. Okay, so for this first one, what I need to do to get a common denominator is multiply by x minus 2 over x minus 2. The second one needs to be multiplied by x plus 3 over x plus 3. And I'm going to essentially multiply this all out and force it to be equal to what I had originally. So I take this a and I multiply it through by the x minus 2 factor, and I get a times x minus a times 2 over x plus 3, x minus 2. Plus I take the second one, bx plus b times 3 over x plus 3 times x minus 2. And then I simplify my numerator. I have ax plus bx minus, I'm actually going to write this as 2a rather than a2, that's kind of weird, plus 3b, all over x plus 3 times x minus 2. Now, if you recall, this was all equal to 2x minus 1 over x plus 3 times x minus 2, which means 2x minus 1 must equal ax plus bx minus 2a plus 3b. Since I have two rational expressions in which the denominators are equal, the numerators must be equal as well. Now what I have is a system of equations because the numerator of the x term over here, 2, must equal the numerator of the x term over here, which I could factor out as a plus b. So in other words, 2x must equal a plus b times x, which means 2 must equal a plus b. okay? And then the constant terms, negative 1, must equal the constant terms over here, negative 2a plus 3b. So negative 2a plus 3b must equal negative 1. And now you have a system of equations. Isn't this fun? You have a system of equations. I think I'd like to multiply this top one by 2 so that I have 2a plus 2b equals 4. And then I'm going to add down. And I get 5b is equal to 3, so b must equal 3/5. And then I'm going to plug that in for b up here. I am so completely out of room. I'm going to finish this over here. I'm really sorry, guys. A plus 3/5 is equal to 2. So a must equal 7/5. All right. Let me talk through this one more time before we move on. What I essentially did was I split it into a sum of rational functions, and then I found common denominators, combined it, set it equal to the original rational function, and I solved for my constants using a system of equations. So my answer, you need to remember this, b is 3/5, a is 7/5. My final answer here is that 2x minus 1 over the quantity x plus 3 times the quantity of x minus 2 is equal to a, which was 7/5 times 1 over x plus 3, plus b, which was 3/5 times 1 over x minus 2. I have done no calculus here. I want to make that abundantly clear to you. What we are doing here is algebra. But what I want to point out is that this expression on the left could not be integrated, but each of these two can. These are actually very easy to integrate, okay? So like I said, we're spending most of the period today on the algebra so that we can then perform the calculus. Originally in here I had you doing one of these on your own the long way. However, I think I'd like to just jump to the shortcut because it works and it's cool and I'd like you to see it. So let's skip this. The easier method is called the Oliver Heaviside method. That's what it's actually called. I'm pretty sure that's the name of the man who developed it, let's say. And it starts out the same. We have to start by factoring the denominator. And again, my denominator came out to x plus 3 times x minus 2. Then you split the factored function into the sum of two partial fractions, just like we did. So far, it's not looking like such a shortcut. This is the cool part, though. What you're going to do is you're going to look at the first factor, the x plus 3, and cover it up with your thumb. Now, I can't show you that here because you wouldn't see my thumb touching my computer screen. That would just be weird. But let's just cover it up like this. And what we do is we plug in the 0 of that factor. So x plus 3, what makes that 0 is negative 3. I plug in negative 3 everywhere else. So I get 2 times negative 3 minus 1 over negative 3 minus 2. And that is my a, okay? And so let's see, this is negative 6 minus 1 over negative 3 minus 2 is negative 5. Lo and behold, that is 7/5, which is what we got for a before. Okay, so a is equal to 7/5 over x plus 3, or we could write that as 7/5 times 1 over x plus 3. Same thing, much shorter way of getting what a is. You do the same thing with b. So I need to clear this ink off of the screen. I don't know how to do that. Let me just clear it. So a was equal to 7/5. For b, I take its factor, x minus 2, and I cover it up with my thumb. And I ask myself, hey, what made that 0? 2. And I plug in 2 to everything else. So 2 times 2 minus 1 over 2 plus 3. What do you know? 3/5. So this is equal to 7/5 times 1 over x plus 3. That's my A. Plus 3/5 times 1 over x minus 2. That's my B. Again, this is still algebra. We've done no calculus, but this allows us to do the calculus. I want you to try one, okay? So please pause the video. No calculus. I just want you to split this rational expression. It says function, but it's an expression, using the method of partial fraction decomposition. Pause the video. Okay, so the first thing you did was you factored the denominator, and it comes out to x minus 5 times x minus 1. I hope you're good at factoring. And then you wrote this as, here's how I actually write it. I write it as something times 1 over x minus 5 plus something times 1 over x minus 1. I actually think that's cleaner than using the a's and the b's. The a's and the b's confuse me. So now I'm going to temporarily, except I can't, cover up the x minus 5. And I'm going to plug in what makes it 0, which is 5. And so I end up with 3 times 5 plus 2 over 5 minus 1, which is 17 over 4 times 1 over x minus 5. Plus, I look at this second one and I see what makes its denominator 0, 1, and I cover that one up. I can actually cover this one up because I'm almost done with the problem. And I plug 1 into everything that's left. So 3 times 1 plus 2 over 1 minus 5, and I get 5 over negative 4 times 1 over x minus 1. Always put a plus sign between them. And then if, for example, your second constant comes out negative, then you can change it to a minus. So I would probably rewrite this as 17/4 times 1 over x minus 5 minus 5/4 times 1 over x minus 1. Let's do some calculus. So this is the problem we just did. Let's see if we can remember what it came out to. I think it was 17/4 times the integral of 1 over x minus 5 minus 5/4 times the integral of 1 over x minus 1. Okay, notice I put the constants out in front of the integrals because they are multiplied through the entire term. And notice I split this into the difference of two integrals rather than leaving it the integral of the difference. Integrals follow that pattern. They follow that rule. That's one of the first rules you learned about integrals. So basically I can take this and rewrite it as this. Now the integration is easy. 17/4. The integral of dx over x minus 5 is just the natural log of the absolute value of x minus 5 minus 5/4. The integral of this is also a natural log times the natural log of the absolute value of x minus 1 plus c. If you need a minute to digest what I just did here, please do that. Please understand the rewrite. I did it so quickly because this is the same expression that we just split a second ago. And I split it into the difference, in this case, of two integrals. It's subtraction because the second constant came out to be negative. Let's try another one. Let's make this one a definite integral. Okay. And so I need to start again by factoring the denominator. And so I have the integral from 1 to 2 of x plus 2 over, factor the denominator, I factor out an x, and I get x squared minus 9. X squared minus 9 is x minus 3 times x plus 3. Okay, this is one where I have 3 factors in the denominator. Doesn't matter, you still cover up the x and plug it into everything that's left. So this is going to come out as the integral from 1 to 2 something times dx over x plus something times the integral from 1 to 2 of dx over x minus 3 plus something times the integral from 1 to 2 of dx over x plus 3. And then I just take these one at a time. I say what makes it 0. I cover that factor up and plug that 0 into everything else. So what makes this first factor 0 is 0. Cover up the x, it's not there, put your thumb over it, and plug 0 into everything else. 0 plus 2 gives me 2 in the numerator. 0 minus 3 is negative 3. 0 plus 3 is positive 3. Negative 3 times 3 is negative 9. So I have 2 over negative 9 as my first coefficient. What makes this one 0 is 3. So I cover up that factor, the x minus 3 factor, and I plug 3 in everywhere else. 3 plus 2 is 5 over 3 times 6. 6 times 3 is 18. What makes this one 0 is negative 3, so I cover it up. And I plug a negative 3 in everywhere else. Negative 3 plus 2 is negative 1 over negative 3 times negative 6 is positive 18. Now I have to integrate. I have negative 2/9 times the natural log of the absolute value of x, and that's evaluated from 1 to 2, plus 5/18 times the natural log of the absolute value of x minus 3, and that's evaluated from 1 to 2, plus negative 1 over 18 times the natural log of the absolute value of x plus 3, and that's evaluated from 1 to 2. I have no plus c because I have a definite integral. Now, oh my goodness, I have to plug in my limits of integration. Negative 2/9 natural log of 2 minus natural log of 1 plus 5/18 natural log of 2 minus 3 is negative 1, but it's an absolute value, so that's going to be a 1, minus natural log of 1 minus 3 is negative 2, but it's an absolute value, so that's going to be positive 2, minus 1/18 times the natural log of, of 5 minus the natural log of 4. And that's a big mess, and I know that these natural log of 1s are equal to 0 and that I could clean some other stuff up here, but I have no room, and let's just say that it's free response. That's it. Okay, so here is homework assignment number 2. I'll spend some time going over it in class tomorrow. It's not a very long assignment. You can use the shortcut for all of these. That's fine. Okay, you do not need to do these the long way. As a side note, in case you're wondering, we are not going to be integrating expressions that have quadratic factors or that have multiplicities other than 1. If you don't know what those things mean, don't worry about it too much. Just understand that only these simpler cases are what come up on the AP exam, and these other situations are really very messy, and I don't want to get into them with you right now. There's one other thing I want to show you. Say what I come out with is 2 times the natural log of x plus 1 plus 2 times the natural log of x minus 5 plus c. Let's say that's my answer. Because my coefficients are equal, and I could technically factor out that 2. You need to remember your log rules. 2 logs with equal coefficients added together are equivalent to the product of their arguments. Yes, adding 2 logs means multiplying their arguments. And if they were subtracted, let me just see if I can get rid of this writing and bring it back up. Let's say I had 2 logs that were subtracted. For example, the natural log of x minus the natural log of x plus 1. Let's say that were my answer, plus c. That would be the same thing as the natural log of x divided by x plus 1 plus c. This is a very, very common multiple choice question on the AP exam, and you better believe they're going to simplify their logs. So I'm not saying you have to do it every single time. I'm saying you need to be aware of it. Okay, that's it for today's lesson.